the main, the computer hardware and software relationship. So that is it. So let's start from instruction fetch and execute. Instruction fetch and execute tonight. Hmm? Is it this diagram that is 3.3? Did not even label it. They refer to one 3.3. Okay, we can't start from there. I think we need to start from here. This particular diagram. Let's check this diagram and see what we can pick from it. This is a CPU. This particular aspect is a CPU, where we have the PC, the MAR, the IR, the execution unit, the input-output AR, and the input-output BR, and also the MAR. I think each of these abbreviations, they have what they mean up here. The CPU exchanges data with memory. That's where we're starting from now. The CPU exchanges data with memory. For this purpose, it's typical makes use of, so it's okay, it's typical, they wrote there. It's typical makes use of two internal, that is to the CPU registers. What did they write? Say, that expression is wrong. What is the meaning of this? These people say registers, a memory address register, MAR. This is what I want us to come and check here. That's why I have to go back. I have to scroll up a bit. Now, the meaning of the MAR that we're seeing under the CPU, which is MAR, is memory address register, which specifies the address in the memory for the next read or write. And memory buffer register, which is MBR, the memory buffer register, MBR, which contains the data to be written into memory, receives the data read from memory. Similarly, an input-output address register. Okay, AR means address register. Let's be marking them now. MAR means memory address register. In any case, the AR there means address register. So for MAR now, memory address register. For the IO, that is, we already know in computer, anytime we see I/O, we are talking about input output. So this IO AR, that is input output address register. And then the IOBR is buffer register, input output buffer register. So when you see B, we're talking about buffer. When we see AR, we're talking about address register. Okay, so we check. So for the MAR, the work of the MAR is it specifies the address in the memory for the next read or write. For instance, it's just like it's want to when an operation of read or write is about to take place. This MAR, that is memory address register, is one to say that okay, you this particular memory, you are the one to take on the next job. It assigns, specifies which memory, which address in memory will be used for the next operation that the computer is about to undergo. But the buffer, that's the memory buffer register, the MBR, that one is one that contains the data to be written into the memory. It receives the data from the memory. That is what the buffer does. Then the IOR, sorry, the IOAR, that is the input output address register, and the buffer, they are used for the exchange of data between an input and output module and the CPU. That is work of the IO, AR, and IOBR, address register and buffer register. The main thing I want us to digest here is the full meaning of all those abbreviations, please. That is why I have to come back here so that we check them out. Because if we just go to the diagram, and please, when we see diagrams like this, let's study them. You know, POP is full of diagrams, so they will give you an exam and say you should draw. So let's be wise. A memory module consists of a set of locations defined by sequentially numbered addresses. A memory module consists of a set of locations defined by sequentially numbered address. When we say sequentially, that means the numbers of those addresses, when if you start from 1, it continues like that. It's not that this one will be 1, that one will be 10, then the next one will be 2. No, it's arranged sequentially. So each location contains a binary number that can be interpreted either as an instruction or data. Each location that you can find in the memory module, don't forget what we are talking about in this paragraph, is a memory module, like a definition for the memory module. So a memory module consists of a set of locations. That is part of the definitions given for the memory module. So what are these locations? We say each location contains a binary number that can be interpreted either as an instruction or a data. Now, an input-output module transfers data from external devices, CPU, and memory, and vice versa. What I think this material is full of errors. What they are trying to say here is that for an input-output module, what it does is it transfers data from the external devices to the CPU and memory. And it can also transfer from the CPU and memory to external devices. Like when you plug in a USB, whether flash or cord connected to a phone to your system, the part that is responsible there is a module transfer, the input-output module transfer. It is the one that manages that address, like manages that operation between external devices and your PC, your CPU and memory. The communication that takes place between them. When you connect anything to your computer that is not part of the computer, what happens there is the input-output module will swing into action. And what it does is it transfer. Of course, you know now, normally when you plug in anything to your system, what you are trying to do is to exchange data between the two things, between your system and of course whatsoever you plug to the system. So far so good. We've talked about the full meaning of some abbreviation like the MAR, memory address register, like the MBR, the memory buffer register, like the IOAR, input output address register, like the IOBR, input output buffer register. And if you remember what we said about MAR, we said MAR is one that specifies MAR, that is MAR, memory address register, is one that specifies which address will be assigned to the next read or write memory. And then the buffer, which is the MBR, the memory buffer register, what that one does is one that holds the data that is to be written into the new memory address. And then we talk about the input and output, both the AR and BR. What they are used for is exchange of data. Because when you say input and output, you are combining two things together, the input and the output. And now we will be talking about something either coming outside the computer into the computer input, and the one going out of the computer to the outside device, which is output. So what those two, whether the buffer or the address memory, once it's under the input output, what they are responsible for is data exchange. both exchange between the system and the external device that you plug to the CPU. And so we said that in the last,
Question.
yes, that's a question or what? So the last thing we mentioned there is that an input-output module transfer, sorry, module, input-output module, that one is responsible for managing data exchange, data communication between external devices and the CPU, and the CPU and the external devices. That is it. And in general, a memory module consists of set of locations defined by sequentially numbered addresses. Now, having looked briefly at these major components, we now turn to an overview of how these components function together to execute programs. So let's go there to that diagram. Now, if you ask to draw a diagram of let's say a memory module or something like that, let's see what we can call this. Is there a label on this diagram so that we'll know if we're asked to draw it, you know the diagram they are referring to. Mm, computer components. Yes, top level view. I think I will try to look for that year. There was one year they asked them to draw this particular thing in the exam. So please let us know what is involved in the top view of a computer component. The top view of the computer components. That is what this drawing is all about. In the top view of the computer component, we have the CPU, we have the input-output module, and we have the main memory. In the uh, under the CPU, when you draw the box to represent the CPU, you talk about the PC, you talk about the MAR. Don't forget what the MAR means, the memory address register. You know, since you have gone up to read about the abbreviations, it's not simple now for us to talk about the diagram. So we are inside the CPU, we have the MAR, memory address register, we have the input register, we have the memory buffer register, we have the input output address register, and we have input output buffer register, and then the execution unit, all inside the CPU. They now communicate with the input output module. Of course, when from the explanation we've gone through above, we found out that the work of input-output module is to exchange data between external devices and the CPU. Don't forget. That is why an arrow is connecting the input-output device module directly to the CPU. So the communication that takes place between them is whatsoever data is being collected from the input-output module is being communicated directly to the CPU for whether conversion or execution. And don't forget that under the input-output module, we have the buffers, if you still remember our explanation above. But that is not all we have in the top view of the computer component. We still have main memory. Mind you, the PC here means program counter. The PC that we have here means program counter. Okay, sorry, this IR is not input register, that is instruction register, but every other thing is correct. The IR means instruction register. So if you draw your drawing like this in the exam, you will do well to label it like this for the examiner to understand that you are not just writing PCIR, you know what they mean. I think that should be a bonus for you. Then we have the main memory. The main memory is arranged in sequential order. Don't forget, there was a place we mentioned that in the last explanation. And you can see the main memory is full of instruction, and of course, data, 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 and data. So I think if you look at this diagram, it's not something we should not be able to draw now if we should meet it in the exam. The part that may be somehow bulky for us to remember is this part of the CPU that contains a lot of abbreviation. But we should remember program counter, instruction register, memory address register, memory buffer register, input output address register, input output buffer register, and then the execution time. Every other thing here, input output module, and then the main memory. They are very simple. In the exam, even if you are not able to recall everything in the CPU, just make sure you remember the order of this diagram. The first box is the CPU. The one at the right here is the main memory, while the one at the bottom is the input output module, and it is connected directly to the CPU, while the CPU connected to the module, the input output module, is having a relationship with the main memory. That is all we are trying to say there. On this, okay, at this point, you let me pause a bit. If you have anything you want to contribute to what we have said so far, or you want to ask a question, let's entertain that. Not be, I'm using lecture method this night, not giving people opportunity to talk. So I'll pause a bit. Any question? Do I even have people in this class?
Yeah, so far no questions, sir. So far no questions.
Okay. So let's read on. The key elements of program execution. Okay, that is from the, in its simplest form, we are talking of this diagram now. Instruction processing consists of two steps. The processor reads, which means fetches instructions. The processor will read or fetch. Another word for that read is fetches or fetch instructions from memory, one at a time, and executes each instruction. What this course is trying to expose to you is the internal part of the operation of the computer. You feed in data to the computer, it processes, and you see result. You maybe if you are a critical thinker, you would have been wondering sometimes that how did this one happen? Like what is happening inside? What is happening? That is what this computer architecture is trying to expose to you. How those operations are happening in the real sense, in the local way, inside the computer, inside the CPU. Not just the one that you just see result on the screen. I'll be wondering how the computer do this thing. You are digging deep now into the architecture of computer. Now, program execution consists of repeating the process of.
Hello, sir.
Yes,
Hello, sir. This processor here is actually talking about the CPU, right?
yes, yes, yes. The processor,
Uh,
your
so,
CPU is the
so, so
processor.
which, so which part of which component of the CPU actually fetches that instruction from the memory?
From memory. That was
Yeah,
when we are talking
which
about
of the
your
components is it?
address register.
Okay, the address register. Okay.
Your address register, if you followed what we read above here, they were talking about the way it operates, especially when we got to the memory module. We say it consists of a set of location. No, not yet. When we're talking about the CPU, we say CPU exchanges data with memory. How? You say for that purpose, it makes use of two internal registers. A memory register, address register, MAR, the one that specifies the address in memory for the next read or write. And the second one, which is MBR, the one that contains the data that want to be read, that will be written into the memory. So if we say MAR is responsible for that in the CPU,
Okay.
but it
Okay. Okay.
specifies uh, The fetch that is there is read. Don't forget what is written here, that they're just that when they put it in the bracket, which means another word for it is fetch. Do you understand?
Go on, sir. Go on, sir.
Okay. So I'm coming. Where are we now? Okay. Mm, so uh, in a very clear term, if you want to create a very clearer picture based on the one we will know before using our control unit, you can say that while your let me use a very clear picture of what we know before to clear this your question. While your RAM used to store instructions as you are working now, RAM is the working memory. While your RAM stores the instructions, the control unit is the one that is fetching it. Both the fetching and the decoding, the interpretation, they takes place. So they all take place in the control unit. While your ALU, arithmetic logic unit, is the one to execute if we have calculation in your data. And then registers will hold the data temporarily. Register holds data, ALU execute calculations, control unit fetches the data, and memory unit is responsible for storing instructions that the data are following in process. So program execution consists of repeating the process of instruction fetch and instruction execution. What this means is that when you are working on a program, probably you launch maybe a browser or anything on your system, and you started doing one or two operations on it. What is just happening is that for everything you are doing and every response and everything that is happening, the computer is just fetching and executing. It fetches data, it executes data. So that is just a continuous operation that is ongoing. It's a repetition. So whether you click another button and something else started happening, what is still happening is in the back of the, let's use the word backend for it. What is happening behind the curtain is computer is fetching data and executing it. That is why you are seeing result. That is why you can just click on the button, you can copy, you can highlight, you can paste, you can do all those things you are doing. Something is happening behind. Computer is fetching data and executing data. That's why they say it's a continuous thing, a repetitive process. It's repeating. It's like a circle. For this thing to happen, I will have to fetch data. This thing that the computer user is telling me to do, I have to fetch data and execute the data. You are giving it the instruction, it's fetching data and is executing your instruction. Now, the instruction execution may involve several operations and depends on the nature of the instruction. You know that all instructions you give to the computer cannot be the same. We have some instructions that will involve calculation. We have some that just text. So let's see. So they say that the instruction execution, the process that will be involved, hmm, it's going to depend on the nature of that your instruction. So let's see the example they want to give us. So the processing required for a single instruction is called an instruction cycle, which means when you give an instruction to the computer, everything involved, everything the computer employs to perform that your instruction is called instruction cycle, which means starting from RAM storing the instruction as you give it to the computer, control unit fetching it, ALU executing it if it's a calculation or calculative instruction, and register holding the data temporarily. All of those cycles, all of those operations or processes happening is what we call instruction circle. So instruction circle is all the processing required for a single instruction. That is taking a bit of instruction now to be completed. Now, using the simplified two-step description given previously, the two-step description given to us, if you remember, is what? Fetches and executes. The computer fetches the CPU, sorry, in the CPU, the control unit, CU, fetches the data and executes the data. So the two steps are referred to as fetch circle and the execute. Fine, they've mentioned it here. The two steps are the fetch circle and the execute. The execute circuit. Sorry, circle, not circuit. The execute circle. Now, program execution halts only if the machine is turned off. I don't know, maybe you've experienced a kind of situation where you are working on a particular program. Probably you open a particular application and you are doing something on it, and the system hangs, maybe due to low RAM or anything, and your system just hangs like that, and nothing seems to be happening. You know that that process will continue and the system will remain hanging except you off your system. So what it means that the program instruction, the program execution, that means the process of the program, the instruction that you issued out to the computer being executed, the process of that execution, the only for it to halt, that means to stop, you have to turn off the computer. And in that process, some sort of unrecoverable errors occur. Yes, you know now when you open a program, and let's say MS Word, and you are typing on that, maybe you've not even saved, and then your computer started lagging, and you have to turn off. You have to do force reboot. And when you do that, by the time you come back, if not now that we have some systems that have all this kind of memory that will still store some of the things you've not even saved for you, and put it one side when you launch the MS Word back. If it's before, the last Control S you press is what you will meet in your document. That's what they're trying to say. So when that kind of issue occurs, that a program is in execution and you turn the system off for one reason or the other, an unrecoverable error occurs to that program, or a program instruction that halts the computer is encountered. Now, instruction fetch and execute, that is what we have next. And I don't know if we should go into that. If we go into it, we need to rush it because we have just 8 minutes left in this class. But in that 8 minutes, I want someone that has been following to recap everything we've said or what you have learned from the class, your own personal gain, your own personal take home for tonight. What is it? Yes, let's use that to end the class. What did you learn tonight? What have you gained from the class? Oh. You could not learn anything. Abi, I'm the only one in the class now.
Hello, sir.
Yes, I'm with you, sir.
Okay, from tonight's class, personally, I've learned about how the computer fetches data and how computer executes data. Like when we look at the components, there are some components of the CPU that are responsible for these actions, like the
Mhm.
fetching and the execution of data.
Mhm.
Like when we look at a CPU, you will see the memory address register, uh, which um, which is responsible for allocating address to a given instruction.
Mm.
So we have the memory buffer register responsible for holding data and incoming data, as in a data that comes into the computer. And also, we'll see about the um, the input output system. That one is responsible for the relationship that exists between the CPU and the external
Devices.
environment. Yeah,
Mm.
that instruction coming into the CPU from the external environment.
Mm.
So we try to look at the top view of the CPU components. And we further stated that um, an instruction cycle consists of the fetch and the execute cycle. That all the activities that happens from when an instruction is being given to a computer to when the particular instruction is being executed, right? From when we impute a data into the computer, how the control unit fetches that data and executes it. And during the course of executing those instructions, some will be temporarily held by the registers. While
Mm.
if it's a mathematical instruction, those instructions will be executed by the arithmetic and logic units.
Mm.
So, but that was what I've learned so far tonight.
Thank you so much. That is wonderful. In fact, you did not leave any stone unturned. That means you've been following. Thank you. Is there any other person that want to say something, that have learned something too? This is the pace we'll be going by. The material is not that long. It's better we go slow and understand than rushing it. There is no gain in wasting your time to join class
Hello,
when
sir.
you don't understand.
Hello,
Yes?
sir. This
Mm.
fetch cycle and the execute cycle, which we refer to as the complete instruction cycles. Um,
Yeah.
are these two steps? Does these two steps
Mm.
do these two steps take place in the control unit
The fetch and execute. Yes,
cycle?
everything takes place in the CU. The CU fetches the data that is already stored in your MAR and so in your MBR, that is the memory buffer address. So when the instruction is there, if we should take it locally, let's use uh, your CPU, sorry, your CU control unit, your RAM, and which other thing can we use? Like, your ALU and your registers. Both the fetching and the execution takes place in the CPU. What others do is that the RAM, of course, all of us know what RAM is, especially when you want to go and get a new phone or a new system. You'll be asking, I don't want small RAM, oh, because you know that when the RAM is small and you are doing so many things at the same time simultaneously, the system will start lagging. It will not be able to carry it because the RAM is the one responsible for storing instruction. Instruction is those things you are doing. Okay, you on this sorry, you launch this particular app that is for editing. You want to edit on it. You launch MS Word, you want to type on it. You launch a browser, you want to browse. Each of them, they are referred to as instruction. You are instructing the computers to do one or two activities on each of those apps you are opening. So the RAM is storing instruction. That is why we call it the working memory. The control unit fetches data from wherever you are. inserting your data from, either from external devices or even from within the system itself. So the CU will fetch it that, okay, this is what we want to work with today. Today we are working with pictures. Okay, you fetch the data. And of course, the execution also takes place in the CU. The only thing is that when we get to talk about the fetch and the execute in full details, I think that is the next topic we are going to. You'll be able to see how those things are happening. When we say that the control unit fetches and executes, what does it use to fetch? What does it use to execute? We'll learn it in the new subheading that we're going to. Look at it. There is even a diagram to help you. Okay, this one is just a basic, but there will be an explanation to that in the next class. Yes, we have less than 1 minute. Is there any other person? If you don't have any other person, thank you all for attending tonight. I think we are making sense already. We are making
Thanks a
progress.
lot, sir.
If you are jotting down, I don't think you have issues with POP by the grace of God. God will help all of us. So good night,
Amen.
everyone. Mm.
Good night, sir.